In the previous class, we discussed about what is divergence. Divergence of any vector is a scalar. Divergence can be represented by like this: del dot a or del dot d bar equal to rho v. That is the divergence theorem. Based on this divergence theorem, it is also known as point form of Gauss law or Gauss law in differential form. It is also called as Maxwell's first equation. Based on this, one numerical problem we will do now. You can understand easily. The numerical problem, let us assume that given, or let us assume that a vector a bar is given as a vector a bar equal to 2xy ax plus zay plus yz square az. This is the vector a, or electric flux density vector can be represented as like this. Find divergence at point P. Find divergence at P, a point P 2 minus 1 comma 3. Assume that, let us we are applying the divergence theorem for any vector. It is a electric flux density vector. It may be electric flux density vector also. It may be d bar. Assume that it is a d bar or a bar. Whatever the vector, we have to calculate divergence at a point P 2 minus 1 3. Given that a bar as, in this x term is, this is the ax, it is the ax term or dx term. If it is an electric flux density, we have to assume that dx it is. Given that a bar, they given as, now ax is ax equal to 2xy. Similarly, ay is z in z direction, in y direction is z, and az is a vector. We are finding az is yz square. Now what is the divergence del dot a equal to rho v, or finding the divergence of this vector? Del dot a equal to divergence of a, that equal to divergence of a. What is the formula? Dou ax by dou x plus dou ay by partial differentiation. We are applying dou ay by dou y plus dou az by dou z. This is the partial differentiation, that is del dot a, divergence of a. Formula is already we discussed previously. Now we are substituting ax, ay, az in del dot a. Del dot a equal to dou by dou x of 2xy. Ax is already we know that 2xy plus dou by dou y of z plus dou by dou z of yz square. We substituted all this. Ax, ay, az already we assumed that this was the ax, ay, az. Ax is this one, ay is this one, az is this one. We substituting, we are doing partial differentiation for that. Let us see that. Dou by dou x of 2xy. Dou by dou x of 2xy, it is x term. It is the x term where we are doing partial differentiation with respect to x only. Dou by dou x of 2xy, what becomes? Only 2x becomes 1. Hence we can write 2y plus, here dou by dou y of z, there is no y term. Hence dou by dou y of z is 0 plus dou by dou z of yz square. Yz square, we have to partial differentiation with respect to z we are doing. That is 2y becomes 2 yz square. Z square y అలాగే ఉంటుంది. yz square ఏమవుతుంది? 2zy it becomes, that equal to 2y plus 2yz. Now we are substituting. The point P is given as 2 comma minus 1 comma 3. 2 comma minus 1 comma 3 it is given. Now we are substituting x equal to 2, y equal to minus 1, z equal to 3. Therefore we are substituting the del dot a equal to 2 into y is minus 1 plus 2 into minus 1 z is 3. Okay, after substituting that, it is what we will get, minus 2 into 1 minus 2 plus 2 into 3 6, 2 into 3 6, it is minus 6 that equal to minus 8. Minus 8 is the answer. The divergence of point A is minus 8.